Hello again, and welcome to Lesson 1.3, Review of Factoring. So just to recall, remember that factoring is basically the reverse process of what we did yesterday in expanding the polynomials. So yesterday we pretty much got rid of anything that was in brackets. Today we're going to do it backwards and try and put things into factors, put things into brackets. A factor is basically just a numerical expression of something that can divide evenly into it. First things first, cardinal rule of factoring, you always check to see if you can common factor. Always. So in this first example, I'm going to take a look at each term, and I'm going to look at all the coefficients, and I'm going to look at all the variables, and I'm going to see if there's something common to all terms. In this first example, I take a look at the coefficients, and I see we have a 5, a negative 20, and a 15. Each one of those are divisible by 5. In all of our terms, there's an x squared, an x, and an x cubed. All of those are divisible by x. And taking a look at the y's, we have at least a y squared in all of the terms. So 5xy squared is my common factor. So that goes on the outside of our brackets. And basically what I'm going to do is we are going to take a look at each term individually, and we're going to divide by our common factor, 5xy squared. So numbers divided by numbers, letters divided by letters. 5 divided by 5 is just 1. X squared divided by x. And then y cubed divided by y squared. And that's it. And then we move on to our next term, the negative 20xy squared. And again, numbers divided by numbers, letters divided by letters. So negative 20 divided by 5. X divided by x is just 1, and y squared divided by y squared is also just 1. Now we take a look at the very last term, 15 x cubed y4 divided by 5x y squared. So 15 divided by 5 is positive 3, x cubed divided by x, and then y to the power of 4 divided by y squared. And I take a look inside the bracket. I see that there's nothing left that's common, so we know we did a good job. Okay, so that's it for that one. For question B, we have two terms here. Remember, a term is separated by either a plus sign or a minus sign. So we have two terms right here. And again, I'm going to see if there's anything that's common to both terms. So outside of the bracket, I see a 2 and a 6c. Both are divisible by 2. The bracket, 4a minus 7b, is also common to both terms. So 2 times 4a minus 7b is my common factor. So we're just going to open up a bracket, and we're going to divide each one of these terms by our common factor. So again, numbers divided by numbers, 2 divided by 2 is just 1. And if I took this entire bracket to the power of 2 divided by 4a minus 7b, well, I end up with a 4a minus 7b. And that's it for that term. So now we'll move on to the next term. We have 6c on the outside, and I'm going to divide that by 2. Well, that leaves me with a positive 3c. And again, this entire bracket divided by 4a minus 7b is just 1. So we're just going to leave that alone. And you'll notice that I tend to do a lot of my work, and I keep things organized in brackets. That's just in case later on down the road we end up having a negative sign and we have to distribute later on. But we'll come across that later, and I'll explain in more detail later on. In any case, we are just going to simplify. And then, so there's no number here, 4a minus 7b, and then plus a 3c. And we are done with that. So that's common factoring. The next type of factoring we're going to talk about is factoring simple trinomials. So a simple trinomial is in the form of ax squared plus bx plus c, where you don't I shouldn't say you don't have a coefficient, but the number in front of x squared is 1. So you don't actually see anything there, it's just the x squared. So what we're going to do is we are going to look for two numbers that multiply to the very last term and add to what the value of b is. So in this first example, I want to try and find two numbers that multiply to 35 and add to negative 12. Those two numbers are negative 7 and negative 5. So because this is a simple trinomial and we don't have any number in front of x squared, we can just open up two sets of brackets that start with x, and then we use those two numbers, negative 7 and negative 5, to fill in the rest of the bracket. So again, we want to find two numbers that multiply to negative 44, and this time add to negative 7. Those two numbers are negative 11 and 4. So same as last time, we open up two sets of brackets that start with x, and we fill in the rest of those brackets with the numbers we chose, negative 11 and 4. Okay, and for our last example, it is still a trinomial, but remember that we always have to common factor first. So taking a look at each term, I see that each term is divisible by 3. So I'm going to take out 3 and divide each term by 3, leaving me with x squared, a 5xy, and negative 24y squared. Okay, so now inside the bracket, we are left with a nice simple trinomial. I want to find two numbers that multiply to negative 24 and add to 5. Those two numbers being positive 8 and negative 3. Now you'll notice that the variables kind of work a little bit different than in previous questions. In previous questions, we just had one variable, the x squared, the x, and then a constant. But if you take a look, the y's, they kind of go in opposite order. So we have no y here, but there's y to the power of 1 and then y. So what we end up with is we still have a trinomial that is factorable. So to factor, same way, we're going to open up two brackets that start with the x. We're still going to use the numbers that we chose to fill in the rest of the bracket, except we're going to add a y to the end of them. Okay, so that's simple trinomials. Now we're going to work with complex trinomials. So they're basically in the same form as a simple trinomial, except this time there is a number in front of x squared that you cannot common factor out. So there are 3 steps. The first thing that we're going to do is we are going to find two values that multiply, this time not to just c, but to whatever 8 and c multiply to. And those two numbers will multiply to ac, and they will also add to b. Later on, we're going to do some factor by grouping and common factoring. So let's work this out. Okay, so we want to factor 6x squared plus 13x minus 5. So as above, we need to multiply our a value and our c value together. So we want to find two numbers that multiply to negative 30 and still add to the middle term. So add to positive 13. These two numbers are 15 and negative 2. We can't just open up two brackets like we did with a simple trinomial. What we need to do is we need to decompose the middle term. So basically what we're going to do is we're just going to rewrite this expression over again, except we are going to break down or decompose this 13x into the numbers we just chose. So positive 15x and then minus 2x. And you can put this in either order. Whichever way you put it in, you'll still get the same answer. We have 4 terms, and with those 4 terms, I'm going to split them into 2 groups of 2. Inside each one of these groups, I'm going to common factor. So inside the first group, I have 6 and 15. Those are both divisible by 3. I have an x squared and an x, so x is common to both. So again, just focusing on this term right here, or this group I should say, I'm going to divide my 6x squared divided by 3x, and that gives me 2x. I'm going to divide the 15x divided by 3x, and that gives me a positive 5. Now, I'm going to try and common factor here. There is nothing that is common. However, in order to do factor by grouping, we need to have terms that are the same. We need to have brackets that are the same. So what I'm going to do is I'm going to take out a -1. And what that does is if I take this term and I divide by -1, I end up with positive 2x. If I take this and divide by -1, I end up with positive 5, which is perfect now because as you can see, I have 2 brackets that are identical, which means I can do more common factoring. Remember, we have 2 terms here. 2 terms. And just like we did on the previous page, in this area right here, we're going to common factor the bracket out, just like we did in example 1b. So I'm just going to go back to our example. Okay, so the bracket 2x plus 5 is what's common. And if I took this term and I divided by 2x plus 5, the 3x is what's left over. And same thing with this term. If I take the 2x plus 5 and I divide by our common factor 2x plus 5, then all that's left is this -1. And we are done factoring. Okay, moving on to a different kind of factoring, difference of squares. So, when you're dealing with difference of squares, you must have 2 terms, both of which are perfect squares, the numbers and the variables, and you must have a minus sign. Okay, so I can't common factor anything here, so I'm just going to go straight into difference of squares. Now, the way that difference of squares works is we're going to open up 2 sets of brackets, and we're going to do some square rooting. So I'm going to square root the first term minus square root the second term. So the number and the variable. And basically you're going to repeat everything except now this gets a plus sign. And that's it for difference of squares. We'll try a more complex example. I can't common factor anything, so nothing is common to 16 and 81. I can see that this is a difference of squares. So, same method as last time. I'm going to open up 2 brackets. And I'm going to square root the first term. And we're going to square root the second term. One bracket gets a minus sign, and one gets a plus sign. With factoring, you always want to go back and double check what's inside of your brackets. So I look inside the second bracket, I see 2 perfect squares. 4 is a perfect square, x squared is a perfect square, and so is 9, and so is y squared. But there's a plus sign in the middle, so I know I can't use difference of squares for this particular bracket. But this first bracket is another example of difference of squares. So we're going to break that down even further. So, open up 2 brackets, square root the first term, square root the second term, one bracket gets a minus sign and one gets a plus sign. And again, We can't do anything to this bracket. We just need to rewrite it. And that's our final statement. The next thing we're going to talk about is perfect square trinomials. You can use decomposition here and you will end up with the same answer. Recognizing that something is a perfect square trinomial will just save you a little bit of time on a test or on your homework. Now, the way that perfect square trinomials works is this. I want you to take a look at the first term and square root it. I want you to take a look at the last term and square root that. And this is how you check if something is a perfect square trinomial or not. You're going to take the square root of the first term, multiply it to the square root of the last term, so 3x times 5y gives us 15xy, and then multiply it by 2, which gives us 30xy. And now take a look. That ended up being our middle term. So, to factor a perfect square trinomial is basically the reverse of the expansion that we did a few days ago. So a squared plus 2ab plus b squared will factor into an a plus b squared. And if you have a perfect square trinomial where the second term is a negative, well, that will just factor into a minus b squared. Okay, so looking back at our example, when you square root the first term, that's going to be our a, and when you square root the last term, that's going to be our b term. So, 9x squared plus 30xy plus 25y squared will factor into a plus b and the entire thing squared. Okay, so we've kind of went through the basics of factoring. A couple examples here so we can kind of double check our work and make sure we understand what's going on. So, before you copy this down into your notes, why don't you take a second, write out the examples, and see if you can do it on your own. If you've already done that, let's work that out. I take a look, and I see that I have two terms here. 1, 2. 2 terms. Okay. Remember, the cardinal rule of factoring is you always want to common factor. So, I take a look at each term. I see the coefficients on the outside, the 3 and the 27, they're both divisible by 3. Inside the bracket, there is nothing common, so the only thing I can common factor out is the 3. That leaves me with x minus y squared minus 9 x plus 2y squared. Alright, so now I'm going to look inside of the bracket, or the square brackets, and I see I still have two terms, x minus y squared, and 9 times x plus 2y squared. I have two terms. Each term is a perfect square. So what I see in front of me is a difference of squares. And remember how that works. Open up two brackets, square root the first term. Well, if I square root the first term, all I'm left with is an x minus y. And if I square root the last term, square root of 9 is 3, and the square root of this bracket squared is just what's inside the bracket. And I'm going to repeat on this side. And remember, one bracket gets a minus sign, and one bracket gets a plus sign. Okay, so the last thing that we need to do is clean up what's inside of those square brackets. We don't want to end up with brackets inside of brackets. So we're going to expand and simplify just inside the brackets. So nothing in front of this bracket here gives me an x minus y. Here, however, we have a negative 3. Distribute the negative and the 3 into the other bracket. Same thing on the side. There's just a 1 here, so I can expand without changing anything. And now we have a positive 3. So positive 3x plus 6y. And then our last step is just collecting like terms inside of those brackets. So x take away 3x gives me negative 2x. Negative y take away 6y. X plus 3x. Negative y plus 6y. Now I notice that inside this bracket I have two negative terms. Generally, for good form, you don't want to have the first term of your bracket to be negative. So what we're going to do is we're going to factor out a negative 1. So basically, we're going to take a negative out of that bracket, which changes the signs just for that bracket. This bracket, we didn't factor out a negative 1. It's going to stay just the way it is. And there we go. That's our final answer. Now, for part B, a lot of people, their first instinct, when they want to do factor by grouping, they end up doing just kind of a default 2 groups of 2. But if you went ahead with this question and you tried to do that, what you're going to notice is you're going to end up with 2 brackets that are not identical. So making 2 groups of 2 in this case is not going to help out. But you're not limited to doing 2 groups of 2. You can do a group of 3 and a group of 1. And the reason I highlighted that group of 3 is because it is a perfect square trinomial. Now remember, perfect square trinomial, I want you to square root the first term, and I want you to square root the last term. Now double check. X times 7y times 2. Does that give you the 14xy in the middle? It definitely does. So I know that this is a perfect square trinomial. Now, if you don't notice that it's a perfect square trinomial, that's okay. Do your decomposition and you'll still end up with the same answer. In any case, we did recognize that this is a perfect square trinomial. So I'm going to write my first term square rooted, my second term square rooted, and we just raise that to the power of 2. So this first group factors nicely into x plus 7y squared. And then we have a negative 36z that follows it. Now we have a difference of squares. Okay, so difference of squares. Open up 2 brackets. Square root the first term. Square root the second term. 1 bracket gets a minus sign, and 1 gets a plus sign. And we're all finished there. So that is the end of factoring. I hope you enjoyed the lesson, and I will see you in class. Take care.